Welcome to the lectures on solar power generation. This is one of the most important lectures in designing the PV systems, and the things which we are going to study in today's lecture are very important, and they are highly related to the field work. When you are practically going to install a PV system for any industry or a home or a stand-alone system, like for telecommunication systems either, there are a lot of calculations you have to make. You should know how to select the batteries, how to select the charge controllers. The main thing you should be able to understand is how to calculate the rating of the PV array. And if there are batteries, then normally we use more than one batteries. And which batteries you will be using and how you will be connecting those batteries. This all stuff is which we are going to cover in today's lecture. We will start with the first example, which is related to a desert area. So here we are going to cover a PV system design example for a remote telecommunication system. Like you have like in the desert area where there is no any other power supply available. What normally the power companies do, they supply power using the generators. And you know that the generators are very costly. Okay, so what industries or what people are now shifting is they are shifting to the solar PV systems. Now, if you have a remote area where there is no any other kind of supply, but there is a good quantity of sunlight, then why not you power your telecommunication equipment or telecommunication tower through the PV system? So whenever you have to design or you have to do the calculations, you first look for the load. That what is the load you have to power up. So in this example, we have a following load. You have a radar system which is of 1500 watts. Then you have lights in that telecommunication tower, they are of 250 watts. And there are some other loads like sensors or other mining and transmitting devices. They consume about 300 watt of power. Now this is the load which we have to power up 24 hours a day. You have to power up this load continuously through PV system. Obviously, it means that there will be some battery storage involved in it as well. So this is our requirement that you have to power up these loads 24 hours a day. Okay, before I proceed on, let's first have a basic layout that which components you will be having to power up this load. Okay, so now let's discuss the layout of the whole PV system. So let's say here you have the load. Then you will be having some inverter, which is DC to AC inverter. Then you will be having some batteries. Then you will be having a charge controller. I recommend you use MPPT charge controller. And then you will be having solar panel. This is the symbolic representation of a PV panel. Obviously, you will be having some series parallel combination. So here I make it by this your PV array. That is the array of solar panels. So this is your PV array. Obviously, the PV array is going to charge this charge controller. supply this charge controller, and charge controller is going to charge the batteries. And then here you have DC, which will be converted to AC because our loads are AC. So this is live and this is neutral. So this will be our basic layout of the whole design. So the thing is that you should be able to know the battery rating, the charge controller rating, the inverter rating, and the rating of this PV array. So this is the important design step. So starting the step, so what we are going to do is that we will first, what we should do, we will first look on the kilowatt hour required by the load. This is the load and you have to run the load 24 hours a day. So the kilowatt hour required by the load, how much it will be? All of these equipments are working 24 hours a day. So just adding their watt powers, 250 watt, and it has a 300 watts. We multiply by 24 hours. So here we get 49.2 kilowatt hour. So this is the total power consumption of the load. That is, you need to provide 49.2 kilowatt hour to the load. Now one thing is important. Here you have an inverter. An inverter is not efficient. Inverters up till now, inverters are around 70% efficient. It means that how much power they are processing, they will also be getting a loss of 30%. So it means that, and obviously this load is to be powered up by batteries through the inverter. So the thing which we are interested in calculating is that how much energy we have to store in the batteries so that this load will be powered up. So inverters are 70% efficient. So adding inverter loss, so this is for 9.2 kilowatt hours, the requirement by the load. Okay. The kilowatt, now we are going to calculate the kilowatt hour required to be stored in the battery. The kilowatt hour to be stored in battery. How much kilowatt hour we need to store in battery? For 9.2 kilowatt hour is the energy consumption of the load per day. Okay, plus since inverter is 70% efficient, it means there is a 30% loss. Adding the losses, we need around 64 kilowatt hour. So how much energy you have to store in the batteries is 64 kilowatt hour. Clear? So it means that we need, okay, one more thing, the charge controller, this is the battery charge controller, it is also inefficient. Okay, and there is around 15% loss in it as well, but this loss varies according to the charging current. So what we do as a thumb rule, we consider that we always take that this, whichever the type of inverter it is, we just assume that our inverter is 70% efficient, because the 30% losses are the losses of the inverter loss, as well as the losses in the charge controller, as well as the losses in your cables. Okay, so we can safely ignore this charge controller's power loss, because we have already compensated it in the power loss in the form of inverter loss. Okay, so it means that we need 64 kilowatt hours from our PV panel each day. Okay, how much energy we require from the sun, or sorry, from the PV panels is 64 kilowatt hours. Now, I'm going to discuss another very important concept with you, and that concept is about peak sunshine hours. I also discussed it, it's a basic idea in our first lecture of module number 1. Oh, sorry, the second lecture of module number 1. What is meant by peak sunshine hours? You know, in most of the countries, generally, sun rises around 7:30 a.m. and sun sets at around 6, let's say 6:30 p.m. Okay, so how many hours there is a sunlight? It is around 11 hours. And you know that at 8 p.m., at 8 a.m., 9 a.m., there is a sunlight available. That is, the sunshine is there, and the sun is providing energy to the PV array, and the PV array is providing energy to the charge controller. But you know that there comes a time of day, like at 12 noon in our countries in Asia, the sunshine is at its peak, and then the sunshine starts to decrease at around 3 p.m. The sunshine is further reduced. So we are receiving a variable energy throughout the day. So the variable power throughout the day. We are receiving the variable power throughout the day. It is depending on the sunshine. So what we generally do is that there is a universal concept that you can assume that the peak sunshine, you can assume peak sunshine hours as 5 hours in Asia. That is, we assume that sun rises only for 5 hours a day, and for the 5 hours, the sun, we are receiving maximum sunshine, and then there is no sunshine. That is, this is a kind of the way of averaging the solar power. That is, we are going to take an average value. Okay, so as I told you that how much energy we are required to receive from this PV array is 64 kilowatt hour, and we assume that the peak sunshine hours are 5 hours in Pakistan, in India, in Afghanistan or Bangladesh. We have 5 hours as a peak sunshine hours. Okay, so what we are going to do is that we are going to divide this 64 kilowatt hour by 5. Okay, so it comes out to be 12.8 kilowatt. Okay, clear what I did? I take an assumption that the sun provides maximum energy, the peak energy, for only 5 hours a day, because this is a kind of an averaging technique. That is, I'm going to take an average value. Okay, so it means that 1 by 5, it means that now the answer is 12.8 kilowatt. It means that the PV panels I require a PV panel which should be rated at 12.8 kilowatt. That is, for this example, I require the PV panel of 12.8 kilowatt. Well, in the market, the single PV panel of 12.8 kilowatt is normally unavailable. Okay, here we have calculated the exact value of the PV panel required. So 12.8 kilowatt PV panel, that is, according to our calculation, there must be a PV panel of 12.8 kilowatt. But in the market, we won't get these huge PV panels that will be able to generate 12.8 kilowatt hour. So what are the available options? Let's say in the market, in the market we typically get the PV panel of around 500 kilowatt easily. So the available option is the PV panel of 500 watts. So you are available with the 500 watt PV panels. So what we're going to do, just 12.8 kilowatt divided by 500 watt, the answer comes out to be 25.6. That is, you require around 26 PV panels, and each must be rated 500 watts. So you require 500 watt multiplied by 26 photovoltaic panels. Okay, and then you will do series parallel combination of those PV panels in order to make the PV array. Let's say what we do. Now look, we are going to discuss the layout of the PV panels. We require 500 watts multiplied by 26 PV panels. So what we are going to do is that let's say this is the 500 watt PV panel and its open circuit voltage V open circuit is around 27 volts. Okay, and let's say we do this combination. For let's say only this combination is we are taking 500 watts is plus sign, here we have minus and then plus and minus. We are connecting them in series and then in the parallel. So here this is the 1000 watt array. This is the panel of 500 watt and this is the 1000 watt PV array. Then what we do in the next step, we just copy them. And how many columns we will be having? This is the first column. This is the second column. And we will be having around 13 columns. This is the 13th column. So now this is what the combination of our PV. This is known as the PV array. This is what you have seen on the rooftops of the different installed systems. And here it comes the charge controller which is connected here. Okay. Then we have done with the calculations that how to calculate the rating of the PV array. Now one more thing is that this is the charge controller. How to select the suitable charge controller. How to select it? It depends on, there are two factors. Number one, you look for the available options. There are many charge controllers which support the voltage rating. Now, what is here? Here is the voltage, and there will be obviously the current rating. The current rating of the charge controller, it depends on the batteries. That is how much current the battery will draw. But the voltage rating of the charge controller, when you will be going to purchase the charge controller from the market, you will have to look on the mentioned rating on the charge controller, that what is the VOC. If you buy a charge controller which supports the V open circuit of 30 volts, then that charge controller will not be suitable for this system, because here the open circuit voltage is around more than 50, it's around 54 volts. So you will have to choose the charge controller whose open circuit voltage is around like 60 to 70 volts. Okay, so that charge controller will be good for you. Now, one more thing. Now, it entirely depends, either you are going to have that required charge controller in the market or not. If not, then what you can do, it is not necessary that you are connecting two PV modules in a column. You may connect 3, you may connect 4. Okay, but whatever you do, your matrix must be symmetrical. Okay, so what you have to do here is 13 columns, and each and every PV module is of same rating. You cannot do this that here is a 500 watt, here is a 500 watt, and here you connect a 300 watt PV module. No, the PV modules which you are using in the array, they must be exactly similar. Okay, understand this thing? So now one more important thing, how to guess the inverter rating. What was our load? Our load was about 2050 watt. Our load, the total watt power of our load is 2050 watt. So how to decide the rating of this inverter? Keeping the knowledge of safety factor in mind, you may add the 30% in this load. So the rating of inverter must be 2050 plus 2050 multiplied by 0.3. So this must be the rating of your inverter, because 30% is the safety margin. Because when most of our inductive loads, when they start, there is a transient current. Okay, so let's calculate this. So this should be the 2.665. So our inverter must not be less than the 2.665 kVA. Okay, so you can you may take it around 3 kVA. So the 3 kVA inverter will be best for our load. Always select the inverter somehow higher rating than the load. Okay, so this is how you calculated, or this is the idea that how you connect the PV array. Now, one more thing which I have to discuss with you about the batteries. We just calculated how much energy we have to store in the battery. how much energy we have to store in the battery. That was a few moments earlier we calculated that we need to store 64 kilowatt hour in the battery. Okay. So we need to store 64 kilowatt hour in the battery. So how to decide for the battery rating? Now, how we start? We take a start using the concept that this is the 64 kilowatt hour multiplied by 1 day. We are keeping the autonomy of the 1 day. That is, if on the next day there are clouds, your battery won't be having the enough charge to power up the load. If you want to design a system that your battery must be able to supply the load to the next day when the sunlight is unavailable due to the clouds, then here you may take autonomy to the 2 days, but I am taking autonomy of only 1 day. So this is actually the formula. This is what the energy to be stored in the battery. Divided by 12. 12 is what? We first assume that the battery is of 12 volts. Multiply by 0.85. That is, the battery is 85% efficient. This is the general rule we usually take when we have to decide for the battery rating. Multiply by 0.7. What does it mean? Battery to be discharged up to 70% of the full charge. That is, in this case, we will discharge our battery not more than 70% of its total energy. You can take it 0.8 or you can take it 0.4. That is, you will discharge battery up to 40% of the full charge, but we are not going to do. You can also take it to 1. That is, your battery will be fully discharged for during 1 day and then it will be charged again. So in general, it's better to take it to be around 0.7. That is, our battery will be discharged up to 70% of its total charge. Okay, so clear with these terms. So our answer comes out to be 9,000 ampere hour. Have you ever seen a huge battery, a big battery having the capacity of 9,000 ampere hours? Obviously, we haven't seen such thing. So how to decide this? So this is this is just like we calculated that a few moments later that we calculated that we need a PV panel of 12.8 kilowatt, and then we said that a big panel of 12.8 kilowatt rating is not available. We have the available options of around we can have the panel of around 500 watt at max. So we divided it by 500, and then we stated that we will be using 26 PV panels. Similarly, a huge battery of 9,000 ampere hours rated at 12 volt capacity is not available in the market. So what you are going to do? So there are many available options. So what is the first available option? Let's look for the batteries available on the international market. Let's see. Let me share my screen with you. And look for the batteries. Let's search using this way. Let's say we look for let's look for some Chinese batteries. Okay. So here we have so here we have obtained a battery which is the tall tubular battery, or so I think here is the best battery I recommend. Let's say we are going to choose this gel battery of 200 ampere hour. So what you have to do, this is the 12 volt 200 ampere hour battery. Okay. Let's calculate for this. Okay, let me zoom in this window. Okay, so I told you that we are going to use this battery. Wait a minute. Okay, so we are going to use we are going to use 200 ampere hour batteries, and each battery is rated at 12 volts. So this is one of the options, but there are some other good options as well. Okay, so we will be having these batteries, the battery 200 ampere hour battery, and we will be connecting these batteries in parallel. So how much batteries we require? we require around 45 batteries. Okay, so here you will be using 45 batteries, and each battery is rated at 200 ampere hour capacity, and and each battery is of 12 volts battery. And which batteries we sorted out? This is the gel battery. But there are other available options as well in the market. When the battery capacity is increased, then the battery voltage are decreased, because most of the manufacturers are manufacturing the batteries having less voltage. When they manufacture the battery of huge rating, then the battery voltage rating decreases. Let me share with you that as well. So here we go. We have sorted out another battery. Let me share my screen with you, and now look. This is another battery I have just sorted out. This is a 2-volt 3000 ampere hour battery, because what is our requirement? We require around 9000 ampere hour battery bank. So a huge battery of 9000 ampere hour of the 12 which is of 12 volt rated is not possible that we will be getting it from the market. So instead of that, you may be using around let's say we look for 1000 ampere hour 2-volt battery. So, or 500 ampere hour 2-volt battery, that will be a bit cheaper. Let's say you have 500 ampere hour battery. So here you have 500 ampere hour 2-volt battery. So which are also available. Now look, this is the solarshop.pk. Here the batteries are available, and this batteries cost around 22,000 rupees. Okay, this is 500 ampere hour 2-volt battery. So what we're gonna do is that we can connect these batteries in series. So this is 2-volt battery, and this is a 500 ampere hour. So you will be connecting these 6 batteries. Okay, plus minus, then plus minus. This is 2-volt battery, 500 ampere hour. So in this way, we can make our combinations. What you have to do, whatever the battery voltage, we started from 12. Okay, now either this is just an indication that you need the 9000 ampere hour battery. Now it is not necessary that you are going to make this 12 volt or battery bank or not. We can make it like, let's say we connect these 6 batteries in series. 1, 2, 3, 4. Let me connect them. Let me connect. Please pause or not. So here you see that what I selected is I have chosen the 2000 ampere hour battery, and each battery is rated at 2 volts. So we have connected 6 batteries in series, and we have made this 12 volt. The main thing to focus is this ampere hour rating. That is, you have to you have to look for this ampere hour rating. Either it is also possible that you may have more than one batteries, like you may choose a single battery of 200 ampere hour of 6 volt each, and you may select any series or parallel combination of the batteries based on your requirement. And one more thing I must mention is that whatever the battery voltage is, your inverter, the inverter you are choosing, and the charge controller you have selection, you have chosen, the battery bank's voltage must be in accordance with the rating of the charge controller, and this voltage must also be in accordance with the inverter rating. So you have to look for different available options of the batteries, and you have to do the series or parallel combination to complete this 9,000 ampere hour battery. Let me discuss some other batteries with you. The available options you have. Now look, here you have, this is a 2 volt 500 ampere hour battery. Then you may also have 2000 ampere hours batteries as well. Now this is available at the Alibaba. This is 2000 ampere hour battery, and this is 2000 ampere hour 2 volt battery. Now look, this is a tubular battery. Okay, and it is making 2 volt. Here it is. This is a 2 volt battery. Okay, so you may have to make a series parallel combination of these batteries. Like let me show you a picture. Battery bank for PV system. So here you look. This is an example that how you connect these batteries. Now there are a lot of batteries in the battery bank. You can see here the batteries are connected in series parallel combination. So it entirely depends on your chosen specifications of the charge controller as well as the inverter. Now look, in this picture you can see number of batteries. This is the battery bank. Look, okay, this is the way you connect these batteries. Understand? So here we end up with this example of the this was in fact the huge example where you are designing a system for a remote area where there is no other power supply available.